Okay, objective 3, I will be able to determine if a function is continuous when given an equation and explain why or why not. So we've done this before. We're just going to actually explain and review this, and it'll lead into the next thing that we're doing. So f of x equals x minus 1. Well, this one's not going to be continuous because if we plug in 1 here, 1 minus 1 is 0. So no, because there is a vertical asymptote at 1. Actually, let's write x equals 1. It's best to get into the habit of writing our asymptotes as lines, so x equals 1. So f of 1 is undefined, therefore, so we'll write f of 1 is undefined. Therefore, f of x is not continuous at 1. Okay, how about this one? Well, you'll notice here that we're actually figuring out why it's not continuous and giving the name, so asymptote or whole or something like that. So we need to go ahead and factor this out to make sure that it's not an asymptote. So I'm going to take, I like to use the I-bar method, a times c is negative 12. Now I need to come up with a couple of numbers that multiply to this and add to this. So right off the bat, I'm thinking 4, 3, and I need it to have a negative here and a positive here. So my bigger number needs to be positive and my smaller number needs to be negative. So 4 times negative 3 does equal negative 12, and 4 minus 3 equals a positive 1. And since I have a number on here, I actually am going to split the middle term with the numbers that I came up with. And then I'm going to factor out from each of these. So I'm going to take out a 2x, and I get x plus 2. And from this one, I'm going to take out a negative 3, and I get x plus 2. Next, I can take out the x plus 2. And I'm left with 2x minus 3 all over x plus 2. And what do you know? Those cancel out. So there is a hole at negative 2. So we want to explain why. And g of negative 2 is undefined. Therefore, g of x is not continuous at negative 2. Okay, so let's look at this one now. And remember that, so these were kind of clear. We saw that there was a 0 in the denominator, and that's why they were not continuous. Here we're going to check to make sure that this is continuous by the definition of continuity. So we need the limit as x approaches 1 from the left of h of x, not f of x, h of x, equal to the limit as x approaches 1 from the right of h of x to be equal to h of 1. So for all the x's that are less than 1, if you can imagine that on the number line, the x's less than 1 are over here, so it's approaching 1 from the left. We have negative 2 times 1 plus 3 to find that limit. And the limits approaching x from the right, so greater than x, are all over here. To find the limit, we can just use substitution. And then lastly, we're actually going to plug in 1 for where we're at 1. So this one's greater than or equals to. This one's just less than. So since it's equals to, this is the point at 1. So we need to take x squared and plug in 1. Now we just needed to make sure that these are all equal to each other. This is a true statement here. So negative 2 times 1 is negative 2 plus 3 is 1. 1 squared is 1, and 1 squared is 1. So because all these parts are equal, h of x is continuous at 1. Okay, so all of this is leading into these kinds of problems here. I will be able to find the value to make the function continuous at a point. So we have the limit as x approaches 1 from the left of f of x has to equal the limit, it's j of x, of j of x as we approach 1 from the right. And it also has to equal j of 1. So when we're approaching it from the left, we're using this equation up here. So a, and we'll use direct substitution right in there. And when we are approaching it from the right, this is the equation that we're using. So 4 times 1 minus 2. And then lastly, j of 1, well, which equation are we going to use? We're going to use the one where it's equal to, or an x is equal to 1, so this equation here. So 1 squared is going to be 1, and then times a is a. 4 times 1 is 4, minus 2 is 2, and then we're going to get the same thing here. So a must be 2 to make the function continuous at the point. Okay, in this case, we don't know what the left and right are, but we do know that the left and right have to be the same. So we're just going to find the limit as x approaches 0, and that means from the left and the right, of k of x, and it has to be equal to k of 0. So I'm going to substitute in. I need limit as x approaches 0 of sine 3x over x. So how can we make it so we don't have a 0 in the denominator? Well, we can multiply by 3 over 3, which then gives us 3 sine 3x all over 3x. These cancel out to 1, and our answer here is 3. And since a, we only have an a here, that would make it so a equals 3. We'll get a little more complicated down here when our letter needs to be solved for. But our answer for this one is just a equals 3. A needs to be 3 for this function to be continuous at 0, because when x equals 0, the y is 3, or a. Okay, once again, we don't see where it's approaching from the left or right, so we're just going to do the limit as x approaches 0 of f of x must be equal to f of 0. So the limit as x approaches 0 of x squared minus 2x all over x, and I'm going to go ahead and simplify this. I'm going to pull out an x, and now I have x minus 2 all over x. These cancel out. Then I can plug in a 0 here. I no longer have the problem of having a 0 in the denominator. So when I put my 0 in here, 0 minus 2 is negative 2. And where x equals 0, I would have to have negative 2 then. So b equals negative 2. Okay, here's one of those where we do know what's going on from the left and from the right. So we'll write it all out. Limit as x approaches 3 from the left of f of x has to be equal to the limit as x approaches 3 from the right of f of x must be equal to f of 3. So for this first one, I'm going to put in my top one here, because from the left is x squared minus 2x minus 3 all over x minus 3. From the right, we have k x minus 2. And then at 3, we would also have k x minus 2. Okay, let's go ahead and simplify this. So let's factor this first. And I get x. And the numbers that I'm going to need in here is a -3 and a +1 all over x minus 3. Okay, these are going to cancel out. And now I can plug in 3 there. So 3 plus 1 equals k times 3 minus 2 equals k times 3 minus 2. 3 plus 1 is 4. Here we have, we still just have 3k minus 2. I'm just simplifying how I write it here. Sorry, that's not a k. There we go. 3k minus 2. And then all we need to do is solve this. We can just pretend like this isn't here and just solve this like it's a two-step equation. So I'm going to take 4, add 2 would be 6, and then divide by 3, and I get k equals 2. So for this function to be continuous at 3, k equals 2. Okay, so for some of these, when you just have a letter here by itself, all you need to do is find out what the value is going to be up here and then just use that for this letter. In this case, we actually have to take it a step further because the letter we didn't have a number for, so we had to find out what x is and then solve. All right, that's it. Thanks for watching.